So now that you've learned all the control structures, what we're going to do is put them all together into one big program called Steeplechase Carol. The idea behind this program is to have Carol run a little steeplechase, which is kind of like a little hurdles race, but it's a way to be able to show you all the control structures that we've seen: for loops, while loops, if statements, all brought together in one big program to solve a bigger problem. So to do that, the first thing we want to do is see what's the program we want to solve. What is a steeplechase? So let me share my screen with you to be able to show you the programming environment that we're going to use for Carol. And the programming environment here, we have a little example, and this is our steeplechase. So what a steeplechase is, it's kind of like a hurdles race. Carol is at corner 1-1 in the world, facing east to start. And what Carol wants to do is jump over all of these different hurdles and eventually get to the end of the race, which is always guaranteed to be 8 columns long. So if Carol moves forward 8 columns, it will end up at location 9, 1. So it'll move all the way over to this location. So let me run this program, and so you can see what Carol's going to do. It needs to go over each of the steeple or hurdles one at a time, basically jumps all the way over it and comes back down. And if it does this 8 times, basically, it's always guaranteed to end up at the end of the race. And so that's where Carol's done. Now, if we think about that, we know that the race is always going to involve Carol moving 8 columns forward. So if we always know how long the race is, that should give us some idea what kind of control structure we might want to use, because we always know the race is going to be the same length in terms of the number of columns that Carol has to go forward. But if we think about now in the race, Carol has to jump the steeples one at a time, or the hurdles one at a time. We don't know how big the hurdles are. The only thing we know is that the hurdles are guaranteed to not go all the way up to the top of the world, because then that would be a box and there would be no way that Carol can jump it. But other than that, the hurdles can be of what we refer to as arbitrary height. They could be as high as they want to be, as long as there's still space up at the top to be able to clear them. So if we don't know how high each hurdle is, that should also give us some idea about maybe what's the control structure we want to use when we think about jumping one hurdle at a time. So a way we can think about approaching a larger problem like this is, how do we break the problem up into smaller pieces? Now, wouldn't it be great if we had some function that could jump one hurdle? Because if we had that, we could just use that a bunch of times to jump all the hurdles. So let's start off by focusing on the problem of being able to jump one hurdle, and then we'll use that in some kind of loop to be able to run the whole race. Okay, so what I want to do is I want to shift over to my slides again, and then we will go through one step at a time to think about how we can actually solve this problem. So let's start off by focusing on the problem of, in the steeplechase, focusing on just one steeple at a time, because we're not guaranteed that every world that the steeplechase is going to look the same way. So we can't just say, well, the first steeple is always 3 high. We need to be able to run any kind of steeplechase as long as the conditions are met. That is, the steeplechase is always 8 columns long, and we're guaranteed that it's possible to jump over each hurdle, that they don't go all the way to the top of the screen. So let's focus on the problem, basically, of being able to jump one steeple at a time. So if we focus on the problem of one steeple, let's say we have Carol here. Carol's facing east, so it's facing the steeple. How would it actually jump over the steeple? The way we could think about that is to say, well, to start off, Carol needs to be facing in a direction upward, or north, as we like to think about it, where it could actually move to be able to jump the steeple. So how would we do that? That one's fairly easy. We'd probably just want to do a turn left. So if Carol executes the turn left, Carol would turn now facing to the north or facing upward. Now, here it gets a little more challenging. How might we think about Carol being able to keep moving until it's gone past the top of this hurdle, or past the top of the steeple? The way you could think about that is, well, if Carol's just looking forward, it doesn't know where the end of the steeple is. But wouldn't it be great if it could say, like, put out an arm on its right side, which would be against the wall of the steeple, and then just keep moving until there was no longer a wall on its right-hand side? That would indicate that Carol had moved all the way up past the steeple. So the way we might think about that, especially if we don't know how high the steeple is going to be, how many places Carol has to move, what kind of control structure do you think we might use there when we want to do something over and over, but we don't know how many times to do it? The while loop is going to be your friend here. So if we think about Carol putting out an arm to the right, so I'm going to put in a little red box that represents Carol sort of putting an arm to the right because it can check whether or not its right is blocked. That's one of the conditions Carol can check in the world. As the condition inside a while loop to say, while your right is blocked, we want you to move. So to execute that, what Carol does is it comes along and says, is my right blocked? Yeah, right now, if I put out my arm to the right, there's a wall there. So I execute the body of the loop, which in this case is just a move. So it moves forward. Then it's done the move, and now it checks the condition of the loop again. Is my right blocked? Yes, it is. So I execute the body of the loop, which is the move. Do it again. Is my right blocked? Yes. So I do another move. Now, at this point, after it's done the move, it comes back to check the condition again. Is my right blocked? And at this point, if you look, Carol's right is no longer blocked. So that condition, right is blocked, is now false. And when the condition becomes false, the loop stops executing and we move past the end of the loop. So we don't do one more move because it's false. We say we are now done with the loop. And so we've successfully gone all the way to the top of the steeple. Now we need to think about what does Carol need to do to be able to jump over the steeple? Well, it probably needs to face back toward the east, which means it needs to do a move to the right. And you might say, but I didn't know Carol could move right. You're right, but remember we wrote move right as a function together before. So we can reuse that function here. So as long as that function is included inside our program, we would need to include that function inside this program to be able to call it. We can call move right, and that will cause Carol to do 3 turn lefts, which essentially is like turning to the right. So I just skipped the 3 turn lefts or did them so fast you couldn't see them, but essentially Carol is turned to the right. Now we want to be able to move over the top of the hurdle. So what do you think we do there? Yeah, not a big surprise. We're going to do a move. And so when we execute that move, Carol moves that one spot forward over the steeple. And now what we want to do is go back down the other side of the steeple. So if we want to go back down the other side of the steeple, that means we have to move to the south. Carol should be facing to the south so Carol can move in that direction. So to get Carol to face to the south, what are we going to do? Turn right. So we do another turn right. If we execute that, Carol would face downward or to the south. And now at this point, Carol is ready to move to the bottom of the screen. Well, in order for Carol to move down to the bottom, again, we don't know how far Carol needs to move down to the bottom of the world. So that's probably going to involve doing something over and over where we don't know how many times we want to do it. And the control structure to use for that, like we used before, is a while loop. Now, the question is, what's the condition we used for the while loop? What will happen when Carol is at the bottom of the world? Well, when Carol gets down to the bottom of the world, its front is no longer going to be clear. So basically what we want Carol to do is to keep moving while its front is clear. That means it'll keep moving downward and when it's facing south until it gets to the bottom of the world, because then there'll be a wall there. You might remember, wait, we did something pretty similar to that, except Carol wasn't moving downward. It was moving across. We had this function called move to wall that we just wrote together a little while ago. Well, in fact, if we had that function in our program where you could just bring in that function, you could just write that function in your program, we could call it here. So just to refresh your memory, here's move to wall. And what that function did is it said, while your front is clear, move. So when we call move to wall, what happens is we call the function and Carol comes along and starts executing move to wall. So it comes in there and says, is my front clear? Yes. So I should now execute the body of the while loop, which is a move. And that's what it does. Then it checks the test again. Is my front clear? Yes, still clear. So it does another move. Is my front clear? Yes. So it does another move. Then it checks the condition on the loop again. Is my front clear? Notice that Carol's front is now blocked. So the condition for the move, front is clear, is no longer true. And so that means that the loop is done. It won't do a final move because when the loop is done, when that condition is false, we don't do the loop one more time. We exit from the loop. And there's nothing else to do inside the move to wall function. So at this point, we're done with move to wall. Now you might say, woohoo, check that out. We just jumped over the hurdle. But there's one final thing we want to do. Remember how we talked about you want your preconditions to match your post conditions, which means before Carol jumped the hurdle, something was true that we want to also be true after the hurdle. You remember what that was? Which direction was Carol facing when we started jumping the hurdle? Carol was facing to the east. Right now, Carol is facing to the south or downward. So we actually want Carol to face to the east again. We should do one final turn left. And when Carol executes it, it will turn left. And notice it is now facing east again. If there was another hurdle there, it would be ready to do the same sequence of steps to jump that hurdle. So we've gotten the post condition, or what's true after we do all this stuff, to kind of match what was true before we did all this stuff, so we can do it over and over. Now, when we look at this, this basically does the work of jumping over one steeple. Now, as we talked about, you want the pre-post condition to match the loop's precondition. That's what we've gotten here, which is great, which means that this is now a sequence of steps we might want to do over and over inside a loop to be able to jump many steeples. But if we also think about what's going on here, we can take this and begin to break it up into smaller pieces. What do I mean by that? What I mean by that is if you look at sort of the first section of code where we turned left, we moved while the right was blocked. So Carol put its arm out and kept moving until it got past the end of the steeple, and then it turned right again. All of that code basically did the work of ascending or going up a hurdle. So we could think about that as ascending the hurdle. Okay, if we had some concept or we wanted to name that. Similarly, if we thought about the code that happened after we did the move that got us over the top of the hurdle, when we turned right, moved to wall until we got to the bottom of the world, and then turned to left again, that work that's now highlighted in green is basically the code to do the equivalent of descending a hurdle or going down the other side of a hurdle. So we could call that descend hurdle. Now, wouldn't it be great if we had functions like ascend hurdle and descend hurdle? That would be great, but we sort of have them. We've kind of just written the code to do that work. So why don't we actually explicitly create functions? So let me take all this code and move it over a little bit to make a little bit more space. And I can say, take that code in the blue and create a new function called ascend hurdle. So I want to define a new function called ascend hurdle, and all that code that was in blue is now part of the body of that function. And what I've done is replaced in the code, what I've done is I've actually added ascend hurdle as a function here, which will call this function over here and do all that work that I was previously having as code just written there. Now I'm actually going to call a separate function to do that work. And I've now named the function ascend hurdle, so it's more clear to the human being what that code is actually doing. Similarly, what I'm going to do is this code over here in green, I'm going to define a new function called descend hurdle. And so I'm going to take this code that's in green, put it inside a function called descend hurdle. And what I've done is now called the descend hurdle function here, replacing that block of code that I had that I've now moved into a separate function called descend hurdle. I can just call descend hurdle. So essentially the work of jumping a hurdle is just ascending the hurdle, doing the move, and then descending the hurdle. And you say, well, if that's all the work of being able to jump a hurdle, can't I just take all of this code and put it inside a function called jump hurdle? Exactly. Now you're beginning to think about how you break the program down into smaller pieces. So I can take this code over here and put it into a new function, and I called it jump hurdle, and it's basically ascending a hurdle, moving, and descending a hurdle, which calls these other functions that we just wrote. So that's the work of jumping one hurdle. Now that we have that, we can think about, okay, let's go back and put this all into a whole program, and we can look at all the code and execute it and make sure that it actually works. Okay, so I'm going to come back over here to our environment for Carol. And so let me take us back to Carol. Here's our little development environment for Carol. Now what I'm going to show you is I'm going to take you through the code for the full steeplechase program. So here's the full steeplechase program. Inside our main.py, we have steeplechase Carol. It has some comment at the top. Remember the importance of comments that says Carol runs a steeplechase that is 9 avenues long. The hurdles are of arbitrary height and placement, which means the hurdles can be anywhere and they can be as high as we want, as long as they don't go to the top of the screen. So what does it mean to run a race? Well, inside our main function, what we do is we have another comment. So remember, you want to, as part of good programming style, every function should have a comment, and you should have a comment up at the top of the program to explain what the program's doing overall. So to jump a race that's 9 avenues long, what we really need to do is either move forward or jump hurdle 8 times, because we start at location 1. And if we go make 8 steps forward, we'll end up at location 9. Okay. So what this does is, since we know the race is always 8 columns long or 8 avenues long, because avenue is sort of the Carol word for a column, Carol name for a column, we have a for loop that counts up to 8 times, right? So it has range 8, and we say, if your front is clear, so if there were no hurdles there, for example, if Carol was on this corner over here where there's no hurdle in front of it, if your front is clear, just do a move. You can just move forward. But if your front is not clear, that means you're facing a steeple. Like in this very first location that Carol's in, its front is not clear, so it's facing a steeple. In that case, it should call the jump hurdle function. What is the jump hurdle function? It's the code we just wrote together. So what is jumping hurdle? It's ascending a hurdle, move, and then descending a hurdle. We wrote that all together. Here's our code for ascending a hurdle. It's turn left while right is blocked. So you put out your right hand and you keep moving as long as you're on the wall. And at the very end, you turn right. Move just would, so that would be the code to take us up to the top of the hurdle. Move would take us across the top of the hurdle. And then descend hurdle over here would turn right, move Carol to the wall down at the bottom, and then turn left. That's what descent hurdle is doing. So that would just get Carol back down to the bottom of the world and then facing east, so it's ready to jump the next hurdle. So if we do those 3 things, we would be in a position to then call jump hurdle again, potentially to jump the next hurdle if it's there. And just to round out this program, to be clear, we need to have our move to wall function that we wrote together before. That needs to be part of this program, which is just while your front is clear, move. And we also need our turn right function, which is just basically a for loop that says turn left 3 times. Okay, so let's run this program and make sure that everything's working. And so you can see now, you can understand everything that's going on in the program as Carol is jumping the hurdles and it's making progress in the world. And we're almost there. Go, Carol, go, Carol. And there we go. Woohoo, we did it. So one of the things that we could also think about is, remember, when Carol's running a steeplechase, the way we wrote our program was to be general. What does that mean? It means that we're not just able to run the steeplechase for this particular world. We should be able to use the same code and have Carol run a steeplechase where the steeples are in different places and are of different heights. As long as it matches the definition for what a steeplechase is, namely that it's going to have 8 columns that Carol needs to move forward, and the steeples don't go all the way to the top of the screen, so they're jumpable by Carol, that's all we need. So let me show you another example. Oh my God, look at this world over here. There's these enormous steeples that Carol needs to jump. But if you look at that world, satisfies the definition of what it means to be a steeplechase. We still want Carol to be able to run this race, move forward 8 columns basically to end up at location 9,1 and jump any hurdles that are on the way. Here's the same code that we had before, and this code was written so that it could solve this different problem. Even though it's a different world, the specification of the world matches what we care about. So if I go ahead and run this program, go Carol, go Carol, go Carol, we can actually see that Carol is executing flawlessly to be able to run the steeplechase that is of a very different size, but because it satisfies all the criteria for a steeplechase that we care about, Carol successfully does the job. So that's how we can take all the pieces of control flow that you've seen in terms of things like for loops, while loops, if statements, and if else, put them all together to be able to solve a big problem. And part of the key to solving that big problem is breaking it up into smaller pieces, creating functions out of those, and then using those to be able to solve the overall problem. So I hope you had fun. We're certainly having fun teaching code in place, and we will see you again soon. Take care. Bye-bye.